Hi there, and welcome to part 2 of arithmetic and geometric sequences. Today we will be writing function rules for arithmetic and geometric sequences. The function rules that we're going to be writing are linear and exponential. So here's our first example. It says to identify the correct form of the following sequence when x is 0, 1, 2, 3, and 4. And if you look at your answer choices, those are function rules. And if you look really closely, you'll notice that they're all linear function rules. So that tells you right there that this sequence of numbers is arithmetic. And you can tell that because to get to the next number, you're subtracting 12 over and over. It's a subtraction. So that's arithmetic. So we see linear function rules. So we need to be able to write or pick from these, write a linear function rule for this sequence. Now, what's important to note is that this sequence was formed when x equals 0, 1, 2, 3, and 4. That's important to note that. So when I plug in 0 into one of these function rules, I get the first term in the sequence there, 17. And then when I plug in the number 1 into the function rule, I would get the next term in the sequence. So in order to organize this, I think it might be helpful if I create a table. I'm going to show you why this is helpful. And then I think you're going to want to do the same thing. Okay, when x is 0, when I plug in 0 into one of the function rules, I'm going to get that first number in the sequence, which is 17. And then when I plug in 1 into one of the function rules, whichever one it is, I'm going to get 5. When I plug in 2, I'm going to get the next number in the sequence. So do you see what's happening here, right? Now, what I can do is use this table to help me come up with a function rule. Now, I have to remember here, this is the x value, and then this is the y value, right? X over y. So that might be helpful too when you look at this table as a horizontal table. Okay, make that x a little bit darker. Okay, so being that this is this is going to be a linear function, I can start my equation y equals, I know I've got mx plus b. And I know that the b is the y-intercept. So I'm going to go right here. The y-intercept is when x is 0. And so I know that that's got to be 17. Okay, so I'm writing a function rule for this sequence by putting it into a table. Now look at the answer choices. You can already narrow it down to 2. Now let's take a look at our rate of change. Do you see what's happening here? We are minusing 12 every single time. Now we see that the x is going up by 1. So negative 12 over 1, that's your slope, negative 12. That's our pattern. And that's repeated. That's why it's multiplication. It's repeated addition. So this is our function rule for this sequence. And it looks like that's going to match up with answer D down here. Now, if we were to plug in 0, 1, 2, all those numbers into this function rule down here for x, we're going to get the sequence that was given to us. Pretty sweet, huh? Very cool. All right, let's try another one. Now, this one's a little different because you're going to see that all the function rules are exponential. So that tells us that this sequence of numbers is, sorry, one second here, is geometric. Oh, I wanted to get pink and it's not letting me get pink. There, pink. Maybe it doesn't want to change. I want pink. There, okay, or purple, whatever. There we go. Yay. Sorry. Okay, so our sequence of numbers is geometric, and you can see that just by looking at times 5 times 5 times 5. Okay, now this sequence of numbers was created when x equals 0, 1, 2, 3, and 4. So let's put this into a table. Remember, it's way easier to write a function rule when you have a table. So when I plug in 0 into one of these functions, I'm going to get the beginning of our sequence, 3. And then when I plug in 1, I would get the next number in the sequence, 15, and so on, 75, and so on, right? Now, I know this is going to be a geometric sequence, so I'm going to start by y equals a times b to the power of x. I know that the first number a is my y-intercept. So right here, when x equals 0, it's 3. Now already I can look and narrow this. Well, I can kind of narrow this down pretty well because there's only one that has 3. Oh, it's that one, right? But you also see that this is multiplying by 5, and so the multiplier is 5. So it absolutely is answer A. See how easy that is? Now, if we were to actually plug in for x, 0, 1, 2, 3, 4, you're going to see that we would end up with this very lovely sequence right here of numbers. Okay, now both of those examples were when x equals 0, 1, 2, 3, 4. Now let's see how this is different in this example. And you're hopefully already noticing that it says when x is 1, 2, 3, 4, okay? All right, so here's my sequence. Looking at these numbers in my sequence, I can tell that it is arithmetic because we are going up by 8, right? Plus 8, plus 8, plus 8. And the sequence was created when x equals 1, 2, 3, 4. So I'm going to start by making a table. Okay, when I plug in x equals 1 into one of these function rules, I'm going to get the first term in the sequence, the 13. And then when I plug in 2, it's going to give me the next term of the sequence. This is how this sequence was created, right, with these numbers for x. These are the inputs, 1, 2, 3, 4, and the outputs are the sequence numbers. Okay, now notice how this is going to be a little bit different. All right. So we got y equals mx plus b. Now, I need the y-intercept here, and I don't have it from the table. I actually have to go back to when x is 0 and figure out when x is 0, what is y. Okay, so if you look in the pattern, it's going up by 8. So that means I have to go backward 8. And if I go backward 8, this would be 5. So this right here is my y-intercept. I have to go back to the 0 term to write the function. So that's 5. And then, of course, it goes plus 8, plus 8, plus 8. So the 8 is the rate of change. And then I can look and see that this matches up with answer choice B. So if I were to plug in 1, 2, 3, 4 into this function for x, I'm going to get the sequence that was given. Well, think about if you just plug in 1 right here for x. 8 times 1 is 8 plus 5 gives us the first term in the sequence. Okay? But if we organize it in a table, you can find the function rule pretty quickly. Okay, let's try another one that's going to be geometric when x equals 1, 2, 3, and 4. Okay, so we have 3, 18, 108, and 648. Now, the sequence was built when x equals 1, 2, 3, 4. So I plugged in 1 for x as my input value into one of these equations, and I get the first term in the sequence, 3. Then I plug in 2, and I get the second term in the sequence, 18. And so on. So I'm just kind of building a table. I don't need every number in there, but might as well. Okay, so I'm getting ready to write my function rule. I know that it's going to be geometric. A times b to the x. Okay, so I need my y-intercept. And it is when x equals 0. So I have to go backward to write my function rule. I have to go back to when x equals 0. What is y? So let's figure out the pattern here. What are we multiplying by? 6, right? So to get back to the 0 term, I'd have to divide by 6. I would have to take this number right here and divide it by 6. So if I take 3 and divide it by 6, that's 1/2. Now do you see how if you take the 1/2 and multiply it by 6, you'll get 3, and then times 6, and so on. So my y-intercept is 1/2. And then the multiplier, the b, the factor of change, is multiplying by 6. So now if I go over here and take a look at my answer choices, I wrote the equation and cool, it matches up. Oh wow, that's I don't know how that how did that circle come to be? I thought I made a circle. But it would obviously match up with answer C. So we wrote the function rule, we just matched it up with the answer choice. All right, number 5. Go ahead and read it. Look at the function rules that you're given. Do you see how they're all exponential? So this is a geometric sequence. There it is. Okay, let's make a table. When I plug in x equals 1 into one of these functions, I get that first term in the sequence, negative 108. Then I have negative 36. And the next one's negative 12. Okay, so let's get ready to write the function rule. Okay, y-intercept. Do you see the problem here? It says x is 1, so I have to go back to when x is 0. I'm gonna kind of, I gotta kind of go diagonal here because that negative 108 is kind of big. So let's look at the pattern, what's happening here. It looks like division, doesn't it? But we need to think multiplication because remember, this is multiplication, right? There's the dot. So it looks like it is dividing by 3, but that's the same thing as multiplying by a third, right? So already I know that this is multiplying by a third. But to get back to the 0 term, I would have to undo that multiply by a third. I'd have to times 3. So if I take negative 108 in my calculator and multiply it by 3, that gives me negative 324. Now, do you see how if I take a third of that, I'll continue the pattern, right? Dividing by 3. So this is negative 324 is my 0 term, which is my y-intercept. Got to have the y-intercept here, and that's your 0 term when x equals 0. Okay, and that looks like it's going to match really nicely with answer C. Cool, we did it. Well, hopefully you feel a little bit more comfortable with this. Now, examples 6 through 9, students in class are going to be trying with a partner and then checking their work. So we're just going to fast forward through that and jump ahead to number 10. All right, on number 10, it says write a function rule for each pattern. Looks like these little tiles, like if you've ever seen anybody tiling a bathroom, these kind of look like those little rubber plus signs that you put in between the corners of the tiles. That's what they remind me of. So we've got 3 figures, right? Think of this as like figure 1, figure 2, figure 3, and then the pattern would continue with figure 4, 5, and 6. Now let's look at the pattern that's happening. Here I see 2 little plus signs, and then do you see how it goes to 4 plus signs? And then it goes to 6 plus signs. So let's think about what are we noticing in the pattern? It is adding 2 little plus signs every single time we go to the next figure, right? So because it's a constant addition pattern that we're seeing, it's going to be a linear function rule, right? It's arithmetic. So it's going to be y equals mx plus b. So hopefully you're making that connection. Now, it's always easiest if you have a table, like an organized table, in order to write your function rule. So I'm just going to kind of make a table out of this. Okay, so I have to go back to the 0 term in order to find my y-intercept. So remember that y-intercept here is when x is 0. So let's back it up. We know that the pattern is plus 2. If this is 2 little plus signs here and here, that means that if I back it up, there would be 0, right? So the y-intercept here is 0. And then this number right here is my rate of change, my pattern that I see. And I see plus 2, plus 2, plus 2 every single time. There's my 2. So really, I could simplify this and take away the plus 0. And my function rule would actually be just y equals 2x. Let's go ahead. We're going to skip the second one and we're going to go on to the next one because it looks like I'm losing disk space. Okay, let's go to number 11 and hopefully I can still be, looks like I'm still recording. Okay, so write a function rule that models this growth. Now with this one, we've got figure 1, figure 1, figure 2, figure 3, and then figure 4, right? So here I see one little dot, and then it goes to 2, and then it goes to 4, and then it goes to 8. Oh my gosh, what's happening here? Well, are you noticing that we are doubling? We are doubling, right? So we can see that this is geometric, and so our function rule is going to be y equals a